Good morning and welcome to the first Environment Subcommittee hearing for the 114th Congress. I want to thank the full committee chairman, Lamar Smith, for his continued leadership. I'd like to congratulate Mr. Loudermilk of Georgia for his assignment as the chairman of the Oversight Subcommittee. Welcome and congratulations. I'd like to welcome back the ranking member, Ms. Bonamici of Oregon, who I look forward to working with in this Congress, and we've worked very well together in the past, and looking forward to another great Congress. And I'd like to congratulate Mr. Beyer of Virginia for his assignment as the ranking member of Oversight on this subcommittee. So congratulations and welcome. This committee has held numerous hearings over the years on NOAA's weather satellite programs. Today we continue this oversight by examining the status of NOAA's two primary satellite systems, the Joint Polar Satellite System, JPSS, and the Geostationary Environmental Operational Satellite System, GOES. These satellites collect vital data that is fed into the numerical weather models that are used by meteorologists to make our forecasts. And where I come from, in the great state of Oklahoma, critically important data for predicting thunderstorms and tornadoes. These two programs comprise the lion's share of funding for NESDAS, the satellite office at NOAA. In the newly released fiscal year 2016 budget request, NESDAS accounts for over $2 billion, roughly 40% of NOAA's total budget. Just 7 years ago, in 2008, NOAA's budget for satellites was less than $1 billion and was roughly 1/4 of NOAA's overall spending. The NESDAS budget has grown dramatically over the last decade. In addition, recent reports from the GAO highlight continuing challenges with NOAA's satellite programs. The JPSS program has been plagued with increasing costs and delays, meaning we are probably facing a gap in satellite coverage and data. Estimates of the data gap range from an optimistic 3 months in some cases to possibly as much as 5 years, depending on circumstances in the worst case scenario outlined by the GAO. With a gap, our ability to predict weather would be dramatically degraded, putting lives and property in danger. This is especially important to me, as my home state is Oklahoma, and we are regularly ravaged by tornadoes. Likewise, the GOES program has also experienced increasing life cycle costs and project delays. With the first satellite launch now pushed back to March of 2016, it is important that the program adhere to its already delayed schedule and prevent another gap in satellite coverage and data. Given the criticality of JPSS and GOES to our forecasts, it is imperative that we ensure these programs receive adequate support and oversight to avoid further delays and cost overruns. I hope we can use this hearing to determine how to keep these programs from slipping even further and mitigate any possible gaps. However, the failures of these programs to stay on track so far highlights a recent track record of our satellite programs that is less than good, and that the paradigm of owning and operating large monolithic satellites might not be the way forward. To address this problem, we should look to augment our satellite systems through commercial means, just as the Department of Defense and NASA have done. There is a burgeoning commercial industry that has incredible potential to assist us in providing accurate information to protect American lives and property, disaggregate risk, and save the taxpayers' dollars. We need to have the most resilient, space-based weather data architecture ever. Instead of continuing down the path of large government-owned satellites that are prone to cost overruns and delays, as we look forward into the future, we must look outside the box for new methods of providing essential weather data. For example, there are private companies such as Planet IQ, Spire, GeoOptics, Tempest Global Data, HiSpec IQ, that have plans to launch constellations of GPS radio occultation and hyperspectral sounding satellites, two sources of data that can greatly enhance our forecasting ability. Considering options that reduce the burden on massive government satellite systems will allow us to more accurately predict weather in future architecture paradigms. It has become increasingly difficult to remain optimistic about the future of U.S. weather forecasting, which currently lags behind the UK, Europe, and Canada in terms of accuracy, when we have satellite programs that are plagued with increasing costs and perpetual delays. The prospect of gaps in satellite data are even higher. We need to look for ways to reduce government burdens and eliminate these types of problems while increasing our ability to protect American lives and property. I look forward to hearing from our witnesses today.